sucking in.
All right, part 1, review. You guys, notes have started, so talking needs to stop. Number 1, we are solving, ladies. Okay, number 1, x over 4 equals 13 over 52. Do you guys remember this from like middle school, how to solve? What's the process called? Cross multiply. All right, 52x equals 13 times 4. 13 times 4 is what? This is 12. What do we get?
52.
52. And then when I solve, I divide both sides by 52. Please stop. I am recording. Seeing if this copy comes out better than the last, because the last one didn't work. X equals what? 1. Okay. Questions on that? Okay. Number 2. Please stop. Number 2. X over 2x plus 1 equals 16 over 40. Okay. This is also a cross multiply. I still multiply here. 40 times x is 40x equals here. Now I'm looking for a particular math word on what I'm supposed to be doing here. Certain vocabulary word. People always forget what to do with the 16. You're on the right track. 16, what's this called? Distribute. Okay, please, I hear talking back there. That needs to stop. Okay, well, you're telling her to wait? Oh, oh, she was saying the answer to what I wanted. Okay, thank you. Distribute. Distribute is correct.
I have a question.
Yes.
So the only time you need to distribute is when like I don't know how to like say what my question
When it's a binomial?
Yeah, like there's two
terms.
Two terms.
Yes, if there are two terms, like here's a monomial, and a monomial, just no distribution. These are monomials. This is a binomial, so yes, you have to distribute when there's 2 or more terms. 40x equals what? 16 times 2?
32.
32x plus 1 or plus 16? Because 16 times 1, B-I-N-O-M-I-A-L. All right, and then we subtract what? Now, some kids do this, and which is okay, but it confuses them, and then they mess up, and then they get it wrong. Why is that not the best way to solve? Because this side's going to be what? 0, and then you get 0 equals, and then they stump up. So what should I subtract instead? 32? 40 take away 32x is? 8x equals?
16.
Divide both sides by 8. What does x equal? Questions? All right. Next piece.
Oh, okay.
Yes? All right. Part 2. Similar polygons. Okay, 2 polygons are similar. 2 polygons are similar if corresponding two polygons are similar. Keyword here is similar. Put that away. 2 polygons are similar if corresponding angles are congruent. And if the lengths of corresponding sides are blank. And I'm not going to put the blank just yet. I want everyone writing this down. Two polygons are similar if corresponding angles are congruent, and if the lengths of corresponding sides are blank. All right. Before we go any further, do you guys agree we've talked about angles being congruent before? Yes? Corresponding parts of congruent triangles are congruent. Do you guys remember that? Yes? If two triangles or two polygons are congruent, then corresponding parts are congruent. What does that mean, corresponding parts? Angles and sides. Now, are we dealing with congruent polygons or similar polygons? Okay, so it's not exactly the same. Is this first part the same? Corresponding angles are congruent. Have we seen that before? Yes. Now this next piece, should I put the lengths of corresponding sides are congruent? No, because then that would make a congruent polygon, and we want it to be similar. So what I put there is they are proportional. When you dilate an image, when you zoom in on a screen and the image gets bigger, or you zoom out and it gets smaller, that's an example of similar polygons. All right. Questions on this? So what do we have to have? What two things have to happen? Angles are congruent and sides are proportional. Not congruent, proportional. Angles congruent, sides are proportional. All right. Questions? All right, I'm going to draw I'm going to try to make it bigger. I didn't do a very good job. All right, I'm going to call this A, B, C, D, G, H, I, J. All right. So I'm going to write the similarity statement. I'm going to show you how to write the similarity statement. A, B, C, D. Why don't I put a little triangle marking here in the front? Because it's not a triangle. All right, I'm going to leave a blank space. I want you to do the same. G, H, I, J. Now I'm going to write this in pencil because I'm going to erase it. So if you're writing in pen, do not write this with me. Is that the correct statement or correct marking that goes in between? No. What is this saying? That the two polygons are what? Equal. Are equal, are the same, are congruent. We're not trying to say they're congruent. We're trying to say they are what? Similar. So does anybody know what the similar statement looks like? It's the squiggly. It's called a tilde. It looks like that. All right, similar. So when you see this, that means they are similar. All right, what two things happen? Let's discuss the angles. What happens to corresponding angles? They are what? Corresponding angles are congruent. I'm going to use my congruent statement. I'm going to put a marking in A. Which angle corresponds with A? What angle corresponds with A? G. What angle corresponds with B? H. Okay, what angle corresponds with C? I. 1, 2, 3, and with D?
You're
J.
saying that the triangles are similar?
The polygons are similar, yes. 3, 4.
Like, that sign can go for anything really, like a square? Or
Yes, any polygon. If the polygons are similar, then yes.
Okay.
Are we good? All right, so how do we write the sides or proportion? You can either use your picture, but you don't need it. You can use this similarity statement just like we did for the angles. So I'm going to go back and forth, use the statement and the picture. I'm going to start here with AB. What side corresponds with AB in the bigger picture? Between 1 and 2, what side corresponds with AB? GH. So I write it like this, AB over GH, because these are going to be my proportions. AB over GH. Equals my next fraction. What side corresponds with BC? So BC over what? HI. Do you guys see how that worked? BC over HI. I'm going to use my statements down here now. Can you see that AB corresponds with GH? And BC corresponds with HI? The next one, let's use our triangle. What would we have? If we did AB, BC, the next one would be CD and what? IJ. Now I've run out of sides on here, but do I still have one more side here? DA, DA and, or AD, it's up to you, DA and JG. Got it? Is that a yes? All right. I'm going to quickly write the congruent angle markings over here because you will have homework questions that ask that. Angle A is congruent to which angle? Angle A is congruent to which angle? G. You can get that from the similarity statement as well. I want you to list the rest. B, C, and D without all the chit-chatting, please. Gentlemen. All right, what do we have for B? H, angle C is what? I and D. Questions before we move on? We're not trying to prove, this is not a problem, this is just what it means to be similar. These two things happen. Corresponding angles are congruent, corresponding sides are proportional, not congruent. Okay. All right, so, go ahead. When this next piece, we're still not trying to find anything, we just want to talk about what is a scale factor. Okay, what is a scale factor? A scale factor is a ratio of corresponding sides. It's a ratio of corresponding sides. All right, for example, this here would be our scale factor. What we had numbers and we reduced them and they all equaled each other. That would be our scale factor. All right, we're going to draw a picture. A, B, C, and X, Y, Z. And I'm going to put one angle tick marking in A and X, 2 in B and Y, and 3, even though it's not needed, in C and Z. Do you agree if I give you 2 congruent angle markings like A and B with X and Y, the third one's not needed because of the third angle theorem? If 2 sets are congruent, then automatically the third is. All right. Okay, so we're going to put numbers in there. I'm going to put, oh, before I put the numbers, is this enough to say the two triangles are congruent? Just angle markings? Angle markings are not enough. What else do I need? I need side markings to know the side lengths are congruent or proportional? Proportional. All right, so let's label. This is 15, 20, 25, 15, 20, 25. This is 6, 8, and 10. All right, I am going to tell you that triangle ABC is similar to triangle XYZ. Please stop. Okay, now a few things. I'm telling you they're similar. Let's say I'm going to cover this, and let's say they're asking you, hey, are these similar? When you're comparing your fractions, kids are often like, if your triangles have been rotated and shifted around and it's hard to tell which side matches up, use your and say they didn't give you this statement. When you make your fractions, keep them in order. Like 15 is your smallest side, so what is 15 going to correspond to? The 6. 20 is your medium. What does 20 correspond with? 8, because that's the medium. And 25 is your largest. What does that correspond with? Small, medium, large, small, medium, large. Use that when they don't give you this statement and the picture's been rotated and it's harder to tell. Does that make sense? All right. How do we find the scale factor? We divide. Good job. All right.
Wait.
Okay.
I have a question. It says on the it says when you said the definition of similar polygons. It says two polygons are similar if corresponding angles are congruent and if the lengths of corresponding sides are proportional.
We're going to check the lengths right now. Okay. Yeah. So let's check if the corresponding, he's saying in the definition we had for similar polygons, they not only had to be congruent for corresponding angles, but sides need to be proportional, the side lengths. Hold on.
No.
Coming back a much? Okay. All right. So, if I were to make my fraction, what would I have? 15 over 10, 15 over 8, or over 6? Over 6, because it's small to small. And I'm just going to go from left to right. And then 20 over 8 and 25 over 10. Let's reduce those. What goes into 15 and 6? What divides into 15 and 6? What divides into 20 and 8? 4. And what divides into 25 and 10? Okay. Reduce them and see if they come out the same. We will in just a little bit. Did they all come out the same? Gentlemen, enough. What did we get as the answer? All of them? 5 over 2, 5 over 2, 5 over 2. Do we agree? Yes. So I gave you this statement, but are these two, did we just prove here that these two triangles are similar? Corresponding angles are what? Congruent. And corresponding sides don't say congruent. Corresponding sides are, starts with a P, proportional. All right, so what is the scale factor? Scale factor of triangle ABC to triangle XYZ. They will give you this statement of this triangle to this triangle, or small to large, or large to small. Whatever, this is going to be the numerator of your fraction, and this will be the denominator. So whatever comes before the 2 goes on top. What comes after the 2 goes on bottom. All right. I'm going to end up with 5 over 2, but I'm just going to pick a side. Because we know it's similar, it does not matter which side you pick. Pick a side. I'm going to pick 25 since you guys didn't give me one fast enough. If I pick 25, which side? Now I'm forced. Can I pick any random side, or am I forced to pick a side? I have to pick 10 because if I picked large, I have to pick large. What does 25 over 10 reduce to? So 5 over 2 is my scale factor. What's another way to write it? Do you guys remember from middle school? 5 to 2. Or there was another way. Do you guys remember it? The 2 dots. Good. 5:2. All right. This is the way we typically write it. Use it, but these way that if you write it this way, it's good. It's fine. It's correct. All right. We're ready for examples. Bless you.
Thank you.
All right. Examples. Shh. All right. List the pairs of congruent angles and the extended.
So the scale factor is basically what we did. That you have. So the scale factor is doing this math right here.
Yes. Yes. He said, is the scale factor doing this math right here? Yes. This right here is called the extended proportion. So when it says here, list the pair of angles, list the pair of congruent angles and the extended proportions. Now, I'm going to, if you don't have this, that's fine. This is pretty much what you're going to have. These two answers right here is what I'm going to ask you for. This is the congruent angles, and this is called the what? Extended proportion. And I'm writing this down so when you look back at notes, you know what that's called, extended proportions. All right. We're ready. Yes.
You're going to get lunch, Miss Torres.
Yes. Thank you. Hold on a second. I can't ever get these looking right. All right, let's get this labeled really quick. V, R, S, T, G, D, E, F, and I'm going to give you the similarity statement. So get this down, and I'm going to write it over here. R, S, T, V is similar to D, E, F, G. And I want you writing all the congruent corresponding angles. How many sets of corresponding angles do I have that are congruent? 4. V to what? Or let's start with R. R to what?
S.
R to
D.
D and S to E and so forth, and then do the proportion, the fraction equals fraction equals fraction. With the fries and ranch. Thank you. All right. Okay, we're ready? Yes, thank you. All right, we're ready? So we have angle R is congruent to angle what? D. Can you tell that right here from your similarity statement? Yes or no?
Yes.
All right. I'm going to do S next. Angle S is congruent to angle what? E. The reason I like using the statement because this is not always going to be drawn nice where you can just look over and see. What am I on? T. Angle T is congruent to angle what? Over here, guys. T to what? T to F, and then angle V to angle G. All right, Now, that's our first set. It did ask for 2. It asked for the extended proportion. Whoever's doing all that squeaking, please stop. All right. RS, what?
I'm going to put it back down.
RS over what? RS over what? DE equals, I'm just going to go in order, ST over what? EF equals TV. I'm right here in the last one. TV over FG, and I've run out. Is there still another one?
Yeah.
Yes, here. TV. Nope. VR, sorry.
Yeah.
VR over what? GD. All right, when you come to these homework questions, are you going to understand and know what to do?
Yes.
All right, last piece before we are done. Any questions here? What was that? All right, that was number 1. I should have put that there. Number 1, list the blah, 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 blah. Okay. Number 2. Guys, I'm going to speed things up a little bit since we now have a hand on it, a handle. All right, triangle, NOP, tilde, triangle, WXY. What does that tilde mean?
Similar.
Similar. This triangle, what is called a what? Please stop. My goodness, third time today. Zip it. Find the following. So that similarity statement is given to you. I am going to draw the pictures. All right. NOP. This is 58 degrees, and this is 49 degrees. WXY. And I'm going to give you numbers. Are we ready? Okay. 4 for OP, 6 for ON, and 10 for XY. A, find the scale factor of triangle NOP to triangle WXY. All right, is this important to know which one comes first?
Yeah.
Yes, it's important to know this statement from triangle blank to triangle blank. Which one's going to go at the top? NOP, bottom, WXY. Now, you have to pick side lengths that have a matching corresponding side. For example, why would I not use the 6? Because what corresponds with the NO in the big triangle? And does it have a corresponding side length over here? No. Does that make sense? And I'm going to give you one more side. I'm going to give you that this is 12. Why would I not use the 12 here? Because it doesn't match with, well, it has an NP, but there's no side length there. What is the only set of corresponding sides that have matching or have numbers? So you are forced. Now, if they gave you a number somewhere else, then you can say, oh, I'm going to use that, and it doesn't matter where you go. Kind of like we did over here. It doesn't matter. I said pick one and go. Now here, it can't be so random. We're forced to use 4 and 10 because that's the only one where I have both numbers for both triangles on corresponding sides. Do you see that? So is it 10 over 4 or 4 over 10? 4 over 10 because it says NOP to WXY, and that reduces to what? 2 over 5. If you want to write it the other way, like this, that is fine, or like this, that is fine, your choice. All right, are we good? Yes.
So let's say they give us all the sides. Can we just use one, or do we have to use all of them?
You only have to use one. If they tell you this is similar and they give you all, you only have to use one. All right. The measure of angle X. let's look quickly. Where's the measure of angle x? Here, what does that correspond to? What does x correspond with? Oh, so what's the measure of angle x?
58.
58 degrees. Part C, the measure of angle y. What does y correspond with? P. Oh no, did they give us P?
No.
Do we have enough information to find it?
Yes.
Can you guys do that really quick? Any one of you, I'll let you guys do it. You have your calculators. Add, and subtract from, what do we get? 73. All right, so what's the measure of angle y? 73. Now this next part, I do need you listening to. This is where kids struggle on the test. What is WX asking for? For this side length here. Do you see that? I'm going to put a letter there. I'm going to put a letter A just so I can call it something when I plug it in. Make your extended proportions. 6 over A equals what? 2 over 5. Now, if you don't want to use 2 over 5, what could you use instead? 4 over... Is 2 over 5 the same as 4 over 10? Yes. So you guys see what I did? Small over large equals small over large. Will this be enough information for you to cross multiply and find A? I want you to do it and check with your group members. I also want you to find NP, and I'm going to call NP C. We'll call that one C. Can you guys help me make up my proportion? Small over large would be C over 12 or 12 over C?
A equals 15.
Right here. C over 12 or 12 over C? C over 12 equals what over what? I'm going to use the 4 and the 10. Does it matter if I use 4 and 10 or 2 and 5? No. No. All right, solve it. Check it with your group members. Solve it. Check it with your group members. What did you guys get for the first one? Letter D. What is it? Anybody?
This is light work. This be senior.
All right, guys, what did you get for D? 15. Thank you, Nathan. Decimal. This one is a decimal. Anybody have it?
I think you meant Bradley.
What is it? 4.8.
I think you meant Bradley. You said Nathan.
Actually, Shelby said.